8.2, we're going to be integrating by parts. So this is going to be a new topic we're going to be learning. So integrating by parts, here are some scenarios on when we need to use it. Okay, when we have x times natural log of x squared times e to the x, or we have a function times a trigonometric function. What is it? Here, this is the by parts. We're going to let u be the easiest part of it and dv be the more complicated part of it. And then we're going to be taking derivative and integrating, and then we're going to do uv minus the integral of v du. Okay, it'll make a lot more sense when we do the example. So again, here's like a little, so let dv be the most complicated portion and let u be the, I guess, the easiest to take derivative. I guess the best part to show you by parts is actually doing the examples. So I'm going to show you 3 examples today. This is the first one. This x e to the x dx. So now I'm going to go to my paper so you guys can see what I'm doing. So this is the integral I need to do right here. And I'm going to write, remember, we're going to let u be the easiest. I'm going to let u be my x. I'm going to let dv, my v's, I put a little hat or a little line through them because my u's and my b's tend to look the same. So I just put a little line through it. We need to find du. So I need to take derivative of this one. Derivative of that would just be 1 dx or just dx. I need to find v. So to find v, we need to do the integral. But the integral of e to the x is simply just e to the x. Okay? So how do I do the integral? The integral, the formula says u dv, which is u dv. It's equal to u times v minus the integral of v du. So let's substitute. U is x. V is e to the x minus the integral of v e to the x. Du is just dx or 1 dx. Okay, we're almost done. Because now the integral of e to the x, we said, is e to the x. So it's going to be x times e to the x minus e to the x plus c. Okay? If you do not remember some of the rules, go back to 8.1 and go back to that slide where it has all different basic integrations that we've learned in calculus. Okay? For example, the integral of e to the x, e to the x. Example 2. Example 2 from my PowerPoint, or the one I want to do, is x squared natural log of x dx. When you are given natural log, I would advise you to use u as your natural log. And your dv, in this case, would be x squared dx. Du, the derivative of natural log of x is 1 over x dx. The integral of this one, find v, we take the integral, we add 1 to the exponent, divide by the number. Okay? Well, I guess I can put plus c, but we don't need it right now. Okay? We'll need it to the very end. So now, I'm going to write my formula again. U dv equals ub minus the integral of du. Again, u. What will be my u? Natural log of x times v. V is x to the third over 3. Minus natural log of x to the third over 3. Okay? Du is 1 over x dx. Okay, Simplify. Let's simplify. I like to move this to the front, or I can x cubed natural log of x all over 3. How I'm going to rewrite this one, I'm going to move the 1/3 outside. One of these x's cancels with this x's. It's going to become 2x squared. And now we integrate this one. So how do we integrate it? We add 1 to the exponent and divide by that number, and we're multiplying. So my last will be x to the 3rd power natural log of x over, I am so sorry, I got carried with the x's, is over 3. 3 times 3 will be 9. And E to make it general. Okay? And that will be my integral. This last one I modified it from the PowerPoint. The PowerPoint has x squared, but the one in WebAssign is only x. So I'm writing it more to look like the one in WebAssign. So in this case, I'm gonna let u be x, and I'm gonna let my dv be sine of 4x dx. Okay? So I need du. I need to take derivative of this, which is b1 dx, or just to take the integral of this. Okay? To do that, or to find v, I need to do the integral. Okay. I guess I'm gonna take like a little break right here. Integral x dx to find v. I need to do the integral to find v. In this case, I need to do another u substitution. I am so sorry. I have the dx, I don't have the 4. So then we're gonna do 1/4 sine of u. The integral of sine is negative cosine, so I'm gonna have negative 1/4 cosine of u or x. This is my integral, which means that's going to be my v. But that's how I got v. That's a little word. But my v will be 1/8 because that's what the integral was. So now, formula. U dv equals uv minus the integral of v du. I am so sorry. There you go. U was x. V, negative 1/4 cosine of 4x minus let me rewrite it again. I don't like how there's a break right there. Can we write it again? Because here we have the integral of v du, but it didn't fit me. Okay, so I'm writing it again right here. Okay, so I have u v minus the integral of u du, which is 1 dx. Okay, let's simplify. I like to move that to the front. So I got negative 1/4 x cosine of 4x. Negative and negative becomes positive 1/4 integral of cosine of 4x dx. Just like I did with the sine, previously. I'm going to take the integral of this, but I don't have the 4 outside. I'm going to take another 1/4, okay? And the integral of cosine is positive sine. So I'm going to have negative 1/4 x cosine of 4x plus it's going to be 1/4 times 1/4, and in this case sine of 4x. Final answer, -1/4. Excuse me. Cosine of 4x, 1/16. Sine of 4x. And that would be my okay. Again, to find the integral cosine of 4x will be similar to the way I found the integral of sine of 4x. Okay.